Hello, this is Kelsey McCarthy. For my assignment, I chose to review the article Teaching Geometry for Deeper Understanding using the 5 Van Hile levels. And I thought that this article was super helpful. It really broke down the expectations of teachers and students and the correct order to introduce all of the levels that involve having academic success through geometry. So there were a lot of very interesting points that were made. A lot of the points were that how difficult it actually is to learn geometry and that it's actually difficult to teach it as well. So the article starts off with part 1, so why is teaching and learning geometry so difficult? And a lot of the reasons for this is that students aren't introduced to it early enough in life. And the article states that, of course, the specific geometry concepts wouldn't be on the same level, but introducing the pattern of thoughts earlier is better. Students need to know how to explain, prove, and show why long before they are in high school geometry. There are low levels of conceptual understanding, and so some students are very quick to pick up things and others take a lot longer. And so the Van Hile levels allow us teachers to get a better understanding for the situations that many students could be experiencing when we are teaching geometry. And his theory describes how students learn geometry. And the article states it is based on the doctoral work of husband and wife, Dinah Van Hile Geldof and Pierre Van Hile. They then go on to explain the general cognitive development. So although there is levels throughout this theory, there is no age, no specific age for whatever level. It really is just focusing on the understanding of the student. And then we typically see that cognitive development actually occur in early adolescence from ages 11 to 20, which I thought that was very interesting. Part 2 later goes on to explain about how the Van Hile levels for geometry learners. It states that the levels are based around the idea that students can understand geometry visually at a young age, then from there develop the concepts behind the properties to the point that they can first just identify, then think more abstract about the principles. So it's starting very basic. It can be introduced to very young students. I mean, as young as kindergarten is often what the article refers to, and that's just showing shapes and saying a rhombus or a kite or a square, really for them to be knowing those shapes is really the first level. And part 3 of the article is ways to teach geometry for deeper understanding using the levels. And so I liked the breakdown included on this one. It says we can incorporate all of this through the abstract and rational levels through all elementary and middle school. So visual recognition in elementary school is seen in grades 2nd through 5th. And then they begin the drawing practice for accuracy of the shapes being learned. Practice the relationships of different shapes that we see in grades 6th through 8th. And the hands-on activities that are really embodying manipulative use through lessons, ideally with some level of inquiry / exploration throughout middle school as well, and teaching students to explain, prove, and show why. That's a huge part of geometry that is often more difficult for students. A lot of times they just want to say, here's the answer, I got it. So level 0 starts out with the visualization. The child can recognize and classify individual shapes based on classic examples. Level 1 is analysis. The student can identify figures or components of figures. She accepts basic, separate properties of geometry. Level 2, abstraction. A student can draw conclusions and is able to order and connect properties. She understands conditions and can begin to use deductive logic, but not yet does understand the meaning of deduction or how to formally show. Level 3, we see deduction. The student has a grasp of reasoning and logic and can communicate to others. He or she is able to construct formal proofs. Level 4 is rigor. The grasp of geometry has been extended to the level of a mathematician. The student has an understanding non-Euclidean geometry and is able to compare the study of geometry to other areas. So those are really the 4 levels that embody teaching the geometry. There's such great examples, thought processes, the challenges where we see this level in most common grades. I think that this article was very, very beneficial. And I think that he's really on to something, Van Hyle, for teachers in order to reach their students through geometry and not having such a rough time throughout all of their math academics through school. Thanks for watching.